the mean value theorem. So before we talk about the mean value theorem, we want to understand what that means. Let's talk about Rolle's theorem. So Rolle's theorem, let f be a continuous function over the closed interval ab, and differentiable over the open interval ab, such that f of a equal to f of b. And the Rolle theorem claims that there is exit 1c in the open interval AB, such that f prime of c is equal to 0. And we can see that to the picture, we draw it. If f of a equal to f of b, then certainly we can see that there exists at least 1c in that interval AB, such that f prime of c equal to 0. So let's prove this theorem, okay? And we consider three cases. So let k equal to f of a equal to f of b, and we have these cases to consider. Case 1, that f of x equal k for all x in the interval AB. This means we're looking at a constant, right? A constant. So if f of x equal k for all x in the interval AB, then f prime of x is equal to 0, right? For all x in the interval AB. So here you can see that there is more than one x value that will make this. There's more than one c value that will make f prime of c equal to 0. Okay? In case 2, there exists an x in the interval AB such that f of x is greater than k. Right? Since f is a continuous function over the closed bounded interval AB, okay? So since f is continuous over the interval AB, by the extreme value theorem, it must have a absolute max and a absolute mean. Okay. Since there is a point x in the interval, also there is a point x in the interval AB such that f of x is greater than k. So then the absolute value, the absolute max value, is greater than k. Okay. So therefore the absolute minimum does not occur at either endpoint. Okay. So this telling us that the absolute min and max are in the interior point of the closed interval AB. Okay. And since f is, because f have the maximum at the interior point of C and f is differentiable at C, then this meant that f prime of C is equal to 0. Okay, and here we have case number 3. In case 3, we will assume that there is an x such that is in the interval AB, so that f of x is less than k. Now you can argue this the same way as you argue for case number 2 to see that there's indeed a list of one value c in that interval such that f prime of c is equal to 0. Okay. Let's take a look at an example. Given the interval x to the third minus 4x, we want to verify that the function satisfies the criteria in the rho theorem and find all the value in C, the interval -2, 0, where f prime of C equal to 0. So first we need to verify that it is satisfied this condition, the rho theorem condition. What are the conditions? Condition in rho theorem saying that f is a continuous over the closed interval, continuous function over the closed interval, and differentiable over the open interval AB, such that f of A equal to f of B. Okay, so let's take a look. So because f of x is a polynomial, it is continuous on the interval -2, 0 and differentiable on the open interval -2, 0. Let's check to make sure that the rho theorem applies. So f of -2 equal -2 to the third minus 4 times -2, that equal -8 plus 8 equal to 0. F of 2 equal to, f of 0 equals 0 to the third minus 4 times 0. This equals 0. This means the rho theorem applies. Okay. So f prime of x is equal to 3x squared minus 4. F prime of x equal to 0 implies 3x squared minus 4 equal to 0. So x squared equal 4 over 3. Then x equal to -4 over 3. And then x equal to -2 over root 3. And 2 over root 3. So these are the two values that would satisfy the rho theorem. Remember, when you do this on the test, you do have to check for the to make sure that the condition of the rho theorem apply before you solve this problem. Okay. Show that a polynomial of degree 3 have at most 3 real roots. Okay, so what does it mean by it have at most 3 real roots? It means it cross the axis at most 3 times. Okay, because f of x is a polynomial Okay. F of x is continuous on an arbitrary interval, and I'll call this negative b to b. Okay. And f of x is differentiable on the open interval negative b to b. So if f of x is the degree 3 polynomial, it is of the form f of x equal ax to the third plus bx squared plus cx plus d. So then f prime of x is equal 3ax squared plus b plus 2bx plus c. This means f prime of x equal to 0. This is the quadratic equation, right? It's telling us that there are at most two values c such that f prime of c is equal to 0. Okay. This meant that f of x has at most two extrema. Okay. So then f of x has at most 3 real roots. The mean value theorem. Suppose that y equal f of x is continuous over a closed interval AB and differentiable on the interval interior AB, then there is at least one point C in AB at which f of b minus f of a divided by b minus a equal to f prime of c. So we're saying that we can find a secant line that is parallel with the tangent line of the function at certain point. Okay. So let's take a look at this first example. Example: if a rock is dropped from a height of 100 feet, its position t second after its drop until it hit the ground is given by this function s of t equal to negative 16 t squared plus 100. Determine how long it takes before the rock hit the ground. When the rock hit the ground, this means s of t equal to 0. So s of t equal to 0 imply negative 16 t squared plus 100 equal to 0. So t squared equal to 100 over 16. This means t equal to plus minus 10 over 4. That is plus or minus 5 over 2. Note that because we're talking about time cannot be negative. So the rock hit the ground at t equal to 5 over 2 seconds. The average velocity is equal to s of 5 over 2 minus s of 0 divide by 5 over 2. We consider the interval from 0 to 5 over 2. Okay. That is equal to 0 minus 100 over 5 over 2. And this is negative 40 feet per second. So that is our average velocity. Now we want to use the mean value theorem to find the instantaneous velocity of the rock. We want to find the time that will guarantee that the instantaneous velocity is the same as the average velocity. Well, we can do that by noting that we want s prime of c is then equal to s of 5 over 2 minus s of 0 divided by 5 over 2 minus 0. Then we want this equal to negative 40. So first, let's find what is f prime of c. What is f prime of t? F prime of t equal to negative 32t. So we want negative 32t is equal to negative 40. So t here equal to 40 over 32. That is 5 over 4 seconds. Okay. So the time when so a t equal to 5 over 4 seconds, the instantaneous velocity is the same as the average velocity, that is negative 40 feet per second. Corollary of this, a function with a derivative 0, let f be a differentiable over the interval I. If f prime of x equals 0 for all x in the interval I, then f of x is the constant. The constant difference theorem, if f and g are differentiable over an interval I and f prime of x equal to g prime of x for all x in I, then f of x equal g of x plus a constant. So remember, when you take a derivative, a constant is equal to 0, right? So when f prime of x equal to g prime of x, it does not guarantee that f of x and g of x is the same, but it's different by a constant. Okay. Increasing and decreasing function. Let f be a continuous over the closed interval AB and differentiable over the open interval AB. If f prime of x is greater than 0 for all x in AB, then f is an increasing function over the interval AB that is closed. And whereas if f prime of x is less than 0 for all x in the interval AB, then x is a decreasing function over AB. Given the acceleration function, we want to find the initial velocity and initial position. Find the object position at time t. We are given the velocity is equal to 32, which means that v of t, well, note that v of t, the derivative of v of t equal to a of t, right? So what do you take the derivative so that you get 32? Well, that will be 32t plus a constant, whatever that constant is. Now I was told that v of 0 equal to 20, so I can figure out that constant. Well, v of 0 equal to 20, so that is 32 times 0 plus c equal to 20. This means c equal to 20. So now I come up with the velocity function is equal to 32t plus 20. Remember, the velocity is the derivative of the position. So the position function, what do you need to take derivative in order to get 32t? So that'll be 16t squared plus 20t plus a constant, whatever that value is, right? And let's double check. Derivative of 16t squared, that's 32t. Derivative of 20t, that is 20. Derivative of c, a constant, equal to 0. And we were told that s of 0 equal 5. This means c equal 5. So then our position function equals 16t squared plus 20t plus 5. Similarly, let's try our next problem. We given 8 of t equal negative 4 sine 2t. Okay. So what do we need to take derivative to get negative 4 sine 2t? Okay. So that derivative of sine is cosine. Derivative of cosine equal negative sine. So this is cosine of 2t. Okay, and look like we have a composite here. So here let's put a 2. So let's double check. V prime of t that equal to negative sine 2t, and derivative of 2t that make 2, and we have a 2 out front, that's another 2, so that can compensate for the 4. Alright, so here we have v of t equal to 2 cosine of t plus c. The v of 0 equal to 2 times cosine of 0 plus c. Cosine of 0 equal 1, so then 1 plus c equal 2. C equal 1. This means our velocity function equal to 2 cosine of 2t plus 1. Let's take a look at how about our position function. So derivative of sine equal cosine. So this is sine of 2t plus t plus c. We were told that s of 0 equal negative 3. This means sine of 0 plus 0 plus c equal negative 3. Sine of 0 equals 0, therefore c equal negative 3. So our position function in this case is sine of 2t plus t minus 3. Given f of x equals sine pi x. Without graphing, identify the interval in which f of x is decreasing and increasing on the interval 0 to 2. The 2 is a little bit bigger than pi over 2, so keep that in mind. So first of all, we need to find the critical value. F of x equal to sine pi x. Then f prime of x is equal to pi times cosine of pi x. F prime of x equal to 0 imply pi times cosine pi x equal to 0. This means pi x cosine equal to 0 at pi over 2 in this interval. So then x equal to 1/2. We consider the closed interval. In our closed interval 0 to 2. So let's take a look at the different interval. We take a look at the interval from 0 to 1/2. The interval from 1/2 to 2, and see whether f prime of x is larger or smaller than 0 in this interval. And by doing that, we use the test value, and we use the test value in each of this. And let's say let test value here x equal to 0, x equal to 1/4, and let x equal 3/4 in this case, or let x equal 1. Okay. Then what is the value of f prime of x in this case? F prime of x equal pi times cosine of pi times 1/4. So pi times cosine of pi over 4. So cosine of pi over 4 is negative, equal to root 2 over 2 times pi. So this value here is positive. f prime of x when x equals 1, then here we have pi times cosine of pi. Cosine of pi equal to -1. So then pi, this is negative pi, right? So here in this interval, it is negative. So because f prime of x is greater than 0 in the interval from 0 to 1/2, then f of x increasing in the interval, the closed interval, 0, 1/2, f of x is decreasing in the interval 1/2 to. Again, so let's recap. How do you find the increasing and decreasing on interval? So you will first find the critical value, then you find the interval in which that the include the interval value and the endpoint. You will use test value to evaluate f prime of x in those interval and determine whether f of x is increasing or decreasing in the interval that you just had.